Alright guys, welcome back. So in the last video we have learned why we need recursion, and we specified various reasons for the need for recursion. So in this module we are going to look at declaration format of recursion method and how it works. So when we create a recursive method, we need to take into account two conditions. A condition where a method calls itself with a smaller values, and the second condition to exit from an infinite loop. So taking into account these two conditions, the basic syntax of recursion will be like this. From the syntax, we can easily see that the mentioned two conditions are implemented over here. So first it checks given condition. If it is satisfied, then it returns some value over here. Otherwise, it continues to call recursive method recursively until the condition is met. Before explaining how recursion works internally, let's look at how a normal method works internally. Okay, let's imagine we have four different functions, and each of these functions calls one another. So the first method calls the second method, then prints out that I am the first method. And the second method calls the third one, and then prints out I am the second method. And the third method conveniently calls the fourth method. Then again, it prints out that I am the third method. And finally, fourth method prints out I am the fourth method without calling any method. So let's see what's happening on the stack memory when we call first method. The stack memory is maintained by the system for the method invocation. You may already know that stack memory works on leave method, which means that the last entered will be removed first. Here, push method is used to insert into a stack, and the pop method is used for removal. If you don't know what the stack is, we will discuss it in the stack section in detail, so you don't need to worry about it. Okay, here we start from first method. As soon as we call first method, the first statement that we see within the first method is to call second method. So the control goes to the second method. After completing the second method, it needs to come back to first method to execute the print statement after the second method calling. So the system needs to store the first method somewhere to come back for executing the rest of code, which is within the first method once the second method execution is done. So the system will push the first method to the stack memory. So in this way, the system remembers that it needs to come back to the first method. Okay, if you look at the second method, we see that this method also calls another method, which is third method. So the system once again needs to store the second method to come back to execute print statement after third method. This one over here. So the second method will be pushed to stack as well. And this is applicable for third method, because it also calls another method within before executing the rest of the code. So it will be pushed to stack as well. The last method is here fourth method, which is executing one line of code without calling any function, which means that the system does not need to store it somewhere for calling back. So it will not be inserted in stack memory. So after finishing execution of fourth method, how does the system know that it needs to go to back and execute third method, not the second method? So this will come from stack memory. As we said, it works based on last in, first out strategy. So the last method that is added to stack is the third method. So this method will be called by the system as a next step to execute the rest of code, which is printing I am the third method. So after this statement, we know that third method is done. So it will be popped out from the stack memory. And here again, the next step will be from stack memory as well, which is second method. So the second method will be called, and the print statement inside second method will be executed. And with this, we know that the execution of second method is complete, which means that it will be popped out from the stack memory. Now the system one more time refers to the stack memory and calls first method and execute the print statement inside the first method, and with this the execution of first method is complete. So the first method will be popped out from the stack memory. So with this, all execution is complete. So now it should be clear how method execution is managed in stack memory. Okay, let's see how a recursive method is stored in stack memory. As an example, we will look at this method over here. This is a recursive function that calls itself. First, it checks if the entered parameter n is less than 1, it prints out that n is less than 1, else it calls itself with parameter n minus 1. So to make things clear, let's run this function for parameter of 4. And let's see how this will be managed in stack memory. When we run this function with parameter of 4, first the system checks that whether 4 is less than 1. We see that 4 is greater than 1, so this means that else statement will be executed, which is calling the recursive function with parameter 3. So recursive method with parameter 4 will be stored in stack memory to come back for executing the print statement after this over here. So when running the function with parameter 3, the system once again checks that if whether the 3 is less than 1, we see that 3 is greater than 1, so this means that else statement will be executed, which is calling the recursive method with parameter 2. So the recursive method with parameter 3 will be stored in stack to come back for executing the print statement after this. So once again, when running the recursive function with the parameter 2, the system checks first if condition. We see that 2 is greater than 1, which means that else statement will be executed, which is calling recursive method with parameter 1. So the recursive method with parameter 2 will be stored in stack memory. So once again, when we're running the function with parameter 1, the system checks that this condition, and we see that 1 equals to 1, so which means that else condition will be executed, which is calling recursive method with parameter 0. So the recursive method with parameter 1 will be stored in stack memory. So when we call recursive method with parameter 0, we see that 0 is less than 1, so the print statement executed, and no need for storing method in stack memory. So to continue the execution, system refers to the stack memory again, so the last method is push to stack will be the first executed, which is recursive method with parameter 1 in our case. So it will call the method with parameter of 1, which will print n out. So in our case, print is 1 because after calling the recursive method with parameter 0, which is 1 minus 1, then we print n here. In our case, n is 1. So the output from recursive method with parameter 1 will be 1. And after calling this method from the stack, it will be popped out from the stack memory. So once this statement executed, the recursive method with parameter 1 is completed. So the system will go to the next method, which is located in stack memory. In our case, it's a recursive method with parameter 2, and this will again print 2. Because when you call this method with parameter 2, it's calling recursive method with parameter 1, it prints out 2, because n is 2. Then after calling this function, the method from stack memory will be popped out. So as a next step, the system will call the next method from stack memory, which is the recursive method with parameter 3, and this will print out 3 as an output. So after executing this method, the recursive method with parameter 3 will be popped out of the stack memory. And as a next step, the last method from the stack will be called, which is recursive method with parameter 4. So when you call this function with parameter 4, after calling this recursive method with parameter 3, here we have output 3, it will print out n, which is 4 in our case. And then recursive method with parameter 4 will be popped out of stack memory. So this is how a recursive method is managed in stack memory internally. Hopefully everything is clear now. So let's recap what we have learned from this lecture. We understood that stack memory is used by the system for managing recursive calls. So every time recursive method calls itself, the system stores it in the stack for coming back. Because there are execution statements left after calling itself, this means that system somehow should remember the point where it stops to call recursive method with different parameter based on the condition for coming back. This is done by storing methods in stack memory. And the stack memory manages the value based on leaf method, which is last in, first out. And this is all for this lecture. Hopefully you have understood everything clearly. So see you in the next lecture.